Hello everyone, and welcome to my first YouTube video ever. My name is Daniel Irizarry, and I just want to say a few words about myself before we go ahead and get started. Last year I graduated from the University of West Florida with my undergraduate degrees in electrical and computer engineering, and for the past year I've been working full-time. So with that being said, I would like to go ahead and jump in and define what is emotion recognition. So in my own words, I define emotion recognition as the problem of observing facial forms from a human and being able to associate a particular facial form with a corresponding emotion. The algorithms I'm going to be talking about here will be a visual approach to emotion recognition. Upon my research, I found numerous topics that use body temperature, body language, tone inflections inside your own voice to be able to bring the data together and associate that with an emotion instead. So this is particularly useful as our machines get more capable and humans begin to interact more with them. In order for the interaction to be natural and fluid, the computer will have to understand the individual's emotions in order for them to adjust their behavior based on what's happening around them in the environment. So I'm sure many of you wondering why I call it the golden ratio. And a little backstory is that I was bored one night bopping around the internet and I came across this website that claimed it could determine the beauty of a face based on this golden ratio phi. So I said, why not? I've already taken 6 pointless Facebook quizzes already tonight. What's one more? So, and what I found out is this golden ratio is a ratio that is constantly at 1.618, commonly rounded up to 1.62. And what it is the long ratio is always 1.61 times the shorter side. Now, the reason why it's talked about so often is that this is a naturally occurring ratio, and it's normally associated with things that have extremely aesthetically pleasing proportions. It's found in architecture, flower petals, it's found in nature, all over the place. So I went ahead and I plugged my face in, and you know what? 7.7, not bad. So I got the idea. If they can quote unquote label a person as beautiful or not based on a number, I can surely base someone's emotions on a number as well. So that's what I set out to do. I'm going to go ahead and jump in right now and talk about the proposed algorithm that I used and able to automate the process so I didn't have to manually click the feature points as you saw on the previous slide. So the steps that I use are, okay, I'm going to go ahead and I'm going to train my program to recognize happy, sad, and a neutral state of emotion. Then it's going to read a frame of my face. It'll send it through horror classifiers to detect specific facial regions. Now, I'm going to differentiate between regions and points. A region in this case signifies a mouth or a set of eyes or a nose or a whole face. And then I'm going to break the face picture down into the individual regions that I just found from the horror classifiers. I'm going to run them through a canny edge detector, which is going to deliver strong edges. So for instance, the corner of my eyes or my lip line. And then once I have the edge image, I scan it vertically from left to right, and I return the first and the last point that I encounter. For example, if I was to scan an eye, that would give me the outside and the inside point of the eye in one pass. So those points are localized though, so I have to scale them back out to the correct location in the entire image. And then from those true locations, I compute specific ratios on the key locations, and then I compare the ratio set to the training data at the beginning. And this algorithm loops forever until I turn off the webcam. On this slide, we can see on the right hand side, this is my face. And on it, these green points I have are the key facial features that I used to find in my algorithm. So this chart on the left gives you a description of what each point was and the algorithm that was used to find it. So for example, this first line at the top of my head corresponds to this point up here. And what I did was I took the horror region of my head and I ran a candy edge over it to decimate out the weak lines that essentially left me with the outside of my face like this. Having already found the edges of my eyes, I found the midpoint of my face based on these 4 points here, and then scanned this column vertically to find the first and the last edge to return my chin and the top of my head. This slide, things get a little bit more interesting as on the right you can see my emotion characteristics. Now these are the outputs that came from my training algorithms prior to my run. I initially only started with these first three, but it turned out that there wasn't enough differentiation and consistency during runtime to be able to support quality emotion recognition. So what I had to do was go ahead and add more points. Now, the sad part is, I know that the only ratio that actually came out to anything close to 1.6 was the top of my head to the width of my face. So that was the only time the golden ratio made an appearance, but it did inspire me to use this approach for emotion classification. So you can see looking from 1 to 6, there's actually a pretty decent spread on each ratio depending on the emotional state. A few complications and caveats associated with my algorithm are mainly false positives. That was the big thing that hit me in the first stage. So on the right hand side, this is the output of the HAR classifiers. So in this case, my lips are designated in red, my nose is designated in green, and my eyes should be designated in blue, but they're not even in this frame. So as you can see, I'm getting a large number of false positives. And I figured that the best way to reduce this was to take the output from the HAR detectors. So it would return in the lips, in this case, it would return 4 regions. And what I did was using generic facial proportions and locations of key regions, such as eyes, nose, and lips. I said, okay, well, my lips have to occur on the bottom 50% of my face, like this. So that went ahead and eliminated 2 false positives. And I used the same approach for the eyes and the nose as well. And it actually turned out that the nose was the hardest. So I knew that the reference point of the detectors is in the top left corner. So I had to draw lines all over my face like this and say search in this specific region only to return consistent results. Another key thing is that the algorithm is sensitive to light and face wrinkles since I'm using a candy edge detector. So the reason why it's sensitive to light is because the nose is actually running a intensity maximum over the specific region. I think the reason why this worked is because I was in front of a computer when I was using this abstraction method, but if I were to walk around outside, I don't think I would get consistent results. So in addition to that, wrinkles on your face, for instance, crow's feet on the outside of your eyes, that can make the width of your eyes expand, or the smile lines that run down from your nose to around the outside of your lips can cause your lips to rise and expand as well. And you might actually see a couple of these during the live demo that's coming up here. But I did have a solution for this. If I was going to expand this project, I would definitely couple the edge detection method with an averaged intensity thresholding algorithm, and I would run a comparison between the outputs of the 2 methods to determine an approximate location for the feature point. That way, say if it's stuck on an outlying wrinkle, but the thresholding algorithm returns a true location, I can at least take a midpoint or something of the sort. Here I just went ahead and I listed my references. They're also included in my report as well, but I think that should be the last slide, so let's go ahead and move on to the demo. This is Python. So I wrote my program in Python, and it's using the OpenCV image processing libraries, and it's also using the HAR cascade classifiers that came with OpenCV in order to detect the facial regions such as nose and eyes and mouth. So go ahead and hit F5, and this begins the training data set. So the data sets are 50 images per emotion, and each emotion is sent into the algorithm, which finds the key face points and computes the ratios for each frame. Once it's completed all 50 frames, it does a running sum of the complete emotion to return a single a ratio array. And that ratio is considered truth for that emotion, which the program now has knowledge of. So it computes the neutral state, the happy state, the sad state, and then it displays the same graph that you saw in my presentation earlier. So I have this popping up just so I can do a visual check of the training data, just to make sure that it's how I am expecting it to look before I go ahead and start the webcam stream. So as for my actual classifier, it's an extremely simple algorithm. This ratios array right up here, that's just the current frame that's being processed, and the neutral, happy, and sad arrays are the truth arrays. So all I do is I come in here and I run a % error check against every single emotion, and then whatever emotion is currently holds the smallest % error to the current frame will be that emotion for that current frame. So it loads a separate array called the current mins, which holds how many emotions won for each ratio, and then I take the mode of that array. So say one feature identified with neutral, one feature identified with sad, and 3 identified with happy, then the happy array would be chosen. And then it just does an if-else logic block to determine what to print. So if we bring this back up and exit out, this will start the webcam. So over here on the left side, it's going to say looking for valid frame if it can't detect a face like this. So that means the classifier couldn't find a frame, couldn't find a face in the frame. So if I come back, it'll start processing again. It'll print neutral for the neutral state, happy for the happy state, and sad for the sad state. And over here on my face, you should hopefully be able to see the purple dots. And those are the algorithms finding the key face features while the algorithm is processing. So I'll move this over, and I'm going to smile. Neutral. So as you can see, sometimes you'll get a little bit of looking for valid frames, or you're going to get some peppered in results. So those frames are typically when you'll have, like, say my nose feature here will just shoot off out onto the side of my cheek, or these lines right here, sometimes these lines will get picked up by my frowning face, and that will, construe the data so that it might think it's a different emotion. So those were some of the caveats that I had listed in my PowerPoint presentation, as far as, possible things going wrong, and, methods that I could use to create a more robust algorithm. All right, well, thanks for watching, guys.